So last time we talked about quadratic functions and we talked about the three different forms of quadratic functions. Today we're going to talk about how we can change from one form to the other. And we saw last time how each form has different things that make it easier to work with, easier to find certain things. So it might be, depending on the situation, easier to use a different form. So to change from transformation or x-intercept form to polynomial form, all you have to do is distribute and then collect any like terms. Now to change from polynomial or transformation form to x-intercept form, this has to do with factoring out the leading coefficient and then either factoring or using the quadratic formula to find the x-intercepts. Alright, so let's start with putting something into polynomial form. So we have f of x equals 0.4 x minus 3 squared plus 2. So what we're going to do here is we are going to start out by writing out this x minus 3 squared as x minus 3x minus 3, and then we're going to need to multiply it all out. So x minus 3 times x minus 3 is going to be x squared minus 3x plus 9, so minus 6x in there. Now note that this entire thing is still in parentheses, and we're going to need to distribute that 0.4. So it's a lot of multiplying and distributing in order to get it into polynomial form. So multiplying this out, we have 0.4x squared minus 2.4x plus 3.6 plus the 2 on the outside, so that gives us plus 5.6. All right, for our next example, we have this 3x squared minus 3.9x minus 43.2. Now we're going to get this into x-intercept form. So we said that to get something into x-intercept form, we're going to first factor out the leading coefficient, and then we'll have to either factor or use the quadratic formula to find the x-intercepts. So first, let's factor out the leading coefficient, which is 3. So 3, parentheses, x squared minus 1.3x minus 14.4. And now to get the x-intercepts, now we're just going to look at the part that's inside the parentheses. So that will be 1.3 plus or minus the square root of negative 1.3 in parentheses squared minus 4 times 1 times negative 14.4 all over 2. The part under the square root ends up being 7.7. So we have 1.3 plus or minus 7.7 over 2. And so we need to actually come up with those two values. So 1.3 plus 7.7 divided by 2, and then 1.3 minus 7.7 divided by 2. So this is going to be 4.5 and negative 3.2. So to put this in x-intercept form, we know what our two x-intercepts are, so this is going to be 3, that was the leading coefficient we factored out, parentheses x minus 4.5, x plus 3.2. Now the harder one to work with is getting something into transformation form. So here we have f of x equals negative 3x squared plus 4x minus 1. Now you'll remember that we worked with how you can complete the square. And so what we're going to do here is going to be very similar to completing the square. Not quite the same, but similar. So let's start with factoring out the leading coefficient. Now we're only going to factor the negative 3 from the first two terms. So let's do that first. So we have negative 3, parentheses, x squared minus 4/3 x, parentheses, minus 1. And then inside the parentheses, now what we're going to do is we are going to figure out what b over 2 squared is, and we are going to add it and subtract it. So because we're working with just one side, unlike completing the square where you add b over 2 squared to both sides, we are going to add the b over 2 squared, and then we're also going to subtract it. So in this case, b over 2 squared is going to be equal to 4/9. So let's go ahead and add 4/9 and subtract 4/9. This way I haven't actually changed the equation. I'm just rewriting it in a way that, well, we definitely don't actually want to simplify it this way, but we can see that if we were going to simplify 4/9 and the minus 4/9, they would cancel each other out. But our point here is we're trying to regroup certain things together, and so by doing this, we're actually able to take the first 3 terms that are inside the parentheses and write it as a perfect square. So 4/3 divided by 2 is equal to negative 2/3. And so that's what b over 2 is, and that's what we can write for our perfect square. So that's going to be x minus 2/3 squared minus 4/9 minus 1. Now we are almost done. We just need to distribute that negative 3 to the x minus 2/3 squared and to the minus 4/9. So for the first part, we're not going to multiply it all out. We just want negative 3 times x minus 2/3 squared. And then we are going to multiply the negative 3 times the negative 4/9, which is positive 4/3. And the last thing we're going to do is we're going to combine the 4/3 and the minus 1, and that's equal to 1/3. All right, we'll do one more example to get something into transformation form. So this is in x-intercept form. So here we have 0.3 times x minus 2 times x plus 1. So first thing I'm going to do is I'm going to go ahead and multiply out the x minus 2 and the x plus 1. So I'm going to end up with x squared minus x minus 2 in the parentheses. All right, so here we're going to do the same thing as we were doing in the previous problem. We're going to determine what b over 2 squared is, and we are going to add and then subtract it inside the parentheses. All right, so b over 2 squared, so negative 1 over 2 squared, that's 1/4. So I'm going to add 0.25 and subtract 0.25. All right, now we're just going to look at the first 3 terms, and the way that we've created this b over 2 squared in here allows us to rewrite this as a perfect square. So this would be x minus 0.5 times x minus 0.5. Again, that 0.5 is just what b over 2 is equal to. So this is x minus 0.5 squared, and then we have to put in the 4th and 5th terms in there, so minus 0.25 minus 2. And we can actually combine those to get minus 2.25, and then we'll distribute that 0.3 over both of those terms. So we have 0.3 times x minus 0.5 squared, and then 0.3 times minus 2.25, which is equal to minus 0.675. All right, and then this last slide is just a chart with a summary of the 3 different forms of quadratic functions, and then how you find the vertex, x-intercepts, and y-intercept for each form. So this is just a reminder and a summary of what we learned last time, and hopefully it's helpful to remind us when we're trying to get from one form to the other what each form looks like.